Question 4. The table shows information about the time, correctly knows minutes, taken by 50 people to complete the race. In a histogram illustrating this data, the height of the block for the 31 to 35 class is 5.6 centimetres. Find the height of the block for the 28 to 30 class. Okay. So the height of a block in a histogram represents the frequency density, doesn't it? The area of the block represents the frequency. So the 31 to 35 class, that actually means 30.5 to 35.5, doesn't it? So the class width is 5. So when we're looking at 31 to 35, we're talking about a class width of 5. And a frequency of 28. And the frequency density is frequency density times the class width gives us 28. So the frequency density of this class is 28 over 5, which is 5.6. And this bar was 5.6 centimetres high. So the scale they're using to represent the histogram is 1 centimetre represents 1 frequency density. So that's quite nice. They've not done any nasty tricks with the scale. Find the height of the block for the 28 to 30 class. So actually this question is now basically saying find the frequency density for the 28 to 30 class. So if we look at that class, 28 to 30, that represents 27.5 to 30.5. So it has a class width of 3. It has a frequency of 4. And the height of this class, well, 3 times its frequency density is going to be equal to 4. So its frequency density is 4/3. So the answer that we're looking for is 4/3 centimetres. And it did say height, so I would think we need to put centimetres on the end there, although they didn't care in the mark scheme. I think I would have cared. It did say find the height. Part 2. The data in the table are used to estimate the median time. State with a reason whether the estimated median time is more than 33, less than 33, or equal to 33 minutes. Okay? Well, to calculate the median, we really need to know something about the cumulative frequency as things go along. There were 50 people. So we're looking for the 25th person. When we're talking about 50, we're kind of, we're thinking, that's kind of the borderline, whether we want to do n plus 1 when we work it out. So it's okay to think about the 25th or the 25.5th person. Right, so that's the first thing to think about. Right, well, according to our table, less than 30.5, there were 4 people. Less than 35.5, there were 32 people. So our middle person stood in the group 31 to 35. That hasn't quite answered our question because it was all about 33 we were thinking about here, isn't it? Now 33 is the midpoint of that group. And we are looking for the 21st person out of the 28 in that group. Does that make sense? Because we're after the 25th person altogether. 4 of them were in the first group. So we want the 21st person out of this group here. Now actually, if there are 28 people in this group, you'd expect, if they were evenly spread, for there to be 14 of them up to 33, and 14 of them between 33 and 35.5. Does that make sense? Because you'd expect the 28 to be evenly spread. So what we're guessing, we're estimating that in the class 30.5 to 33 there would be 14 people, and 33 to 35.5 there would be another 14 people. So which 14 does the 21st person come in? The 21st would be in the middle of those 14. And that's enough for us to say, therefore, we would expect the person to be more than 33 minutes as our estimate of the median time. It's a bit of a tricky question, isn't it? It's a bit of an unusual level of detail for us to go into for doing that. Okay. Part 3. Calculate estimates of the mean and standard deviation of the data. So having done all of that, we've now got quite a lot of work to do with this, because this is where we use the midpoints and do our whole table and do all of that stuff. So, the midpoints of our groups are... Oh, this is going to be really dull. The midpoints are the x values, and I need to look at my... I'm not going to keep scrolling back up, so I'm just going to look at it here. The midpoints would be 29, halfway through that first group, has a frequency of 4, 33 with a frequency of 28. What's the next midpoint? 36 plus 45 divided by 2. The next midpoint is 40.5, has a frequency of 14. The next one the midpoint is 53, halfway between 46 and 60, and that has a frequency of 4. So we've taken our midpoints of each of the groups and worked out our frequencies. So the job now is to work out the fx and the fx squared columns. So fx comes from doing, this is really dumb, isn't it? 29 times 4, 33 times 28, 40.5 times 14, 53 times 4, and the fx squared, that's 29 squared times 4, 33 squared times 28, 40.5 squared times 14, and 53 squared times 4. Okay, and we need totals. Well, this total should add up to 50, shouldn't it? Does it? Yes. So this total, 116 plus 924 plus 567 plus 212 is 1819. That's sigma fx. This is 50, of course, sigma f. And this one, I hate this kind of number crunching aspect to it. It's just irritating, isn't it? This gives us 68055.5 sigma fx squared. So the mean is sigma fx over sigma f. So we're doing 1819 over 50, and That's 36.38. And they wanted the standard deviation, didn't they? So the standard deviation is the square root of sigma fx squared over sigma f minus our mean squared. So it's the square root of 68055.5 over 50 minus, and we've got that is the exact version of that, but we're going to be careful that we do use the exact version, whatever's gone on before. We might have to have stored it in our calculator. Minus 36.38 squared. I'm getting 6.13, the three significant figures, as my standard deviation for that. Great. Last part said, calculate, oh yeah, it was found that the winner's time had been incorrectly recorded. It was actually less than 27 minutes 30 seconds. Wow. Well done, winner. State whether each of the following will increase, decrease, or remain the same. Right. Okay, so that's one of the values has moved down, hasn't it? So what do we think about the mean? Takes into account all the values. Our sigma fx is going to be slightly smaller because one of the values is slightly less. So the mean will decrease, won't it? Happy with that?
Yeah.
So, this is part 4. The mean will be lower. Standard deviation. The smallest value has moved further away from the largest value. The person won the race by a greater amount. So the spread of the data has increased. So the standard deviation will increase. Okay, things got spread out a little bit more. C is the median, is it? Is that right? Yeah. Okay. The middle person had exactly the same time, didn't they? The fact that the fastest person was slightly faster doesn't change the order of where people finished, doesn't change where the middle person finished. The same. Makes no difference. And the interquartile range, which we never actually worked out, well, it's the same deal, isn't it? The interquartile range tells us about the middle 50%. So if the winner happened to be faster, the winner weren't in the middle 50%, the same. And we can stop the video.